Hello all, I'm Dr. Rizvi and this is fifth lecture on Mohr circle. In this lecture we'll solve another problem on Mohr circle. So let's start with the question. It states that at a point in a bracket the stresses on two perpendicular planes are 35 meganewton and 15 meganewton and both are tensile in nature. It is also experiencing a shear stress across the plane and it is having a magnitude of 9 meganewton per meter square. In this question, we have to find the normal, the tangential, and resultant stress and its obliquity at a plane that is at 40 degree with the plane of first stress. So, to start with the question, we initially have to draw the diagram. So, let us draw the diagram for the question. Here is the element that is experiencing two tensile stresses on two planes that are mutually perpendicular. Sigma x is 35 meganewton per meter square and sigma y is 15 meganewton per meter square. It is also experiencing the shear stress along the planes. So let us mark the shear stresses. Tau is 9 meganewton per meter square. It is like this. On major principal plane it is in anti-clockwise direction and in minor principal plane it is in clockwise direction, and we know that clockwise direction shear stresses are positive and anti-clockwise direction shear stresses are negative. After drawing the diagram, the next step is to scale the stresses. So let us take the scale. Here the maximum stress that we are getting is 35 meganewton. So let us assume that 1 centimeter on our scale is equals to 5 meganewton per meter square. So sigma x will be 7 centimeter since it is 35 meganewton per meter square. Sigma y will be equals to 3 centimeter and tau will be equals to 1.8 centimeter. We have to find the value of sigma n, sigma t, sigma r on this plane, which is at an angle of 40 degree with the first stress. Now the diagram is also complete and we have done the scaling. So let us start with the Mohr circle. We'll draw the y-axis, we'll draw the x-axis. This is y. We have also made some assumptions in the first lecture, and on the basis of assumption the tensile direct stresses are plotted on positive x-axis and the shear stress is plotted on y-axis. Clockwise shear stresses are plotted on positive y-axis and anti-clockwise on negative y-axis and positive y-axis. Let us do the marking. 1, 2, 3, 4, 5, 6, 7. We'll mark this point as A. OA equals to sigma x and OB equals to sigma y. Sigma y equals to 3 centimeter, so we'll mark B at 3 centimeter. We'll take now we'll mark the shear stresses. Since 35 meganewton plane is experiencing anti-clockwise shear stress, so it will be plotted here and it will be 1.8 meter downwards, 1.8 centimeter downwards, and at point B on the minor principal plane it will be 1.8 centimeter in positive y-axis. Mark this point as D and this point as E. After drawing the shear stresses on along point A and B, we will now join point E and D with the help of a scale, and The point at which this line ED cuts the x-axis, mark that point as C, and this will be the center of the Mohr circle. With CD or CE as radius, draw a circle. This will be the Mohr circle for the given question. To calculate the value of normal, tangential and resultant stress, we'll now mark this 40 degree on this Mohr circle, and we know that through assumptions the angle is taken as twice, so it will be 80 degree, 2 theta. We'll place the protector here on point C and we'll measure 80 degree from here, and we'll extend this line such that it meets the Mohr circle at point F. This is 80 degree from here. From F, we'll drop a perpendicular on x-axis and mark this point as G. Join O and F. We know that this distance from F to G is sigma t. From G to O, it is sigma n. From O to F, it is sigma r. And this is phi, the angle of obliquity. So you can write as OD equals to sigma n, that is normal stress, OG. FG equals to tangential stress, and OF equals to sigma r. We'll measure the angle FOG and it will be equals to phi through protector. This is how we will solve the numerical having two mutually perpendicular stress and a shear stress. Thanks for watching the video. Thank you.